So this topic is on linear modeling. The concepts that we'll be covering today are correlation, Pearson's correlation coefficient, line of best fit, the least squares regression line, and interpolation and extrapolation. Starting with correlation, this should be a pretty quick review. Positively correlated, negatively correlated, these are both linear models, right? And this one's a scatter, so it means that there is no correlation. A correlation is the relationship or the association between two variables, usually the variables on your x and the variable on your y. Linearity. So which one follows a linear trend? This again should be really fast. It should be the last one. Strengths of linearity. Here you see three different levels. This is how we categorize the strength. The strongest one is, you see majority of the data is very much around the line of best fit. Moderate means they're kind of generally well within a range. And weak means that it's scattered with a very wide range of x and y values. Outliers, they are the data points that do not really fall along the general trend. Correlation and causation. So causation does not mean that, if something is correlated, if something is positively or negatively correlated, it must mean that one of them causes the other. So that's not the case, right? Causation occurs. This is going to require you to think the x and y independent and dependent variables through, but whether or not there is a causation involved. So here's an example. So the number of ice cream sold on Wednesdays in the cafeteria shows a strong positive correlation between the number of cutleries returned during lunchtime that day. So does this mean that if more students buy ice cream, then more cutleries will be returned in the cafeteria? So the answer to that should be no, right? So it doesn't mean that more students buying ice cream will cause more cutleries to be returned. It just so happened that there is a positive increase in the independent or dependent variables such that it forms a positive linear correlation. But that doesn't mean that that is causation. The next thing is on Pearson's correlation coefficient. Pearson's correlation coefficient ranges from -1 to 1. So it's usually indicated by the letter R, correlation coefficient, and the size of this R indicates the strength. So remember just now we saw the three different levels of strength, strong, moderate, and weak. We can use R, Pearson's correlation coefficient, to determine which one it is. So when R value equals to 1, then that's perfect positive correlation, which means it's strong, very strong, right? When it's -1, then it means the opposite. And then as you go down from 1 to 0, you slowly lose correlation to the point where the bottom of this table, 0 to 0.1, means no correlation. Again, you see that the inequality, less than or equal to, is only in the lower range and not in the upper range. So for the size of R indicating the strength of correlation, you could usually write it as thus. So X bar and Y bar meaning the means, averages, right? And then you have a set of data points. And so you would plug this in and you would be able to find R. R would be in 1 to -1 range. It shouldn't be outside of that range. An easier way, beyond using this formula, is using your calculator. So calculating, what you can do is, for example, this screen right here. You get to the screen by inputting your x and y data. So if they give you a data set of x and y, you go to Stat on your calculator, Edit, and Enter. Edit should be the number 1 button. And then you input your x values and your y values in that order. right? Always put independent in the first column and dependent in the second. After you input your data, then you press Stat again, go to Calc. It's the second tab on top. The first tab is Edit. The second tab is Calc. And then the fourth option is the linear regression. This entire topic is on linear modeling, so you should only be using linear regressions. And then it'll give you this output. So with this output, you could see the R value here is negative 0.8. So this falls within which bracket? Falls within the moderate positive correlation. That one is the fourth one on that data table. So line of best fit. The first process is to calculate the mean X and Y values. And then mark this on a scattergram. So mark your X and Y mean value. Then mark the line of best fit through the mean point by I. So this is just going to be a general, what do you think would be a good line that passes through the mean values that you found that shows a general trend of your data set. So it looks like this. So this red line is a marked line of best fit through the mean point that was calculated by I. Using least squares regression line is a better option than drawing the line of best fit by eye, right? Because there's definitely going to be subjectivity to what you feel and what another person feels the line of best fit should be. So least squares regression line is a more calculative way of solving it. So it's the exact same process, right? Do you see how the linear regression screen, this output, looks exactly the same as the previous one? Linear regression means that it's a linear equation, so it's y equals mx plus b. They tell you that m here is a and b here is still b. So you just need to read off the calculation from your TI-84 and write out your equation. So in this case, y equals to 0.0402x plus 18.1. Again, they'll give you a data set with x and y independent, dependent variables, and you need to go through this process to find it. So finally, we lead to the last point on interpolation and extrapolation. So there is an upper and a lower pole. This means the highest, right, and the lowest value. And well within these two values are going to be your interpolation. Any values that's outside the data set, essentially, where you end up predicting what it looks like at x equals to 1,000 or x equals to -5, which obviously isn't in this data set, then that's called extrapolation. So you just need to know the difference between extrapolation and interpolation. All the data points that fall within the range, that's interpolation, okay? And then extrapolation is outside, whether it be negative infinity or positive infinity. This line here is not the one that you draw through the mean points by eye. This one is the least squares regression line. Okay, so when it's TI-84 and when you're calculating it through the most accurate possible way to determine the line of best fit, that's called the least squares regression line. And then you can see the R value to tell you whether or not there is a strong, moderate, or weak correlation.